Hello friends, I am Kisan Singhala and I am studying in Information and Communication Technology at Marwadi University. Today I will explain about cyclic redundancy check, which was assigned as a term and project for Java and Introduction to Communication Engineering. Let's see what is a cyclic redundancy check. A cyclic redundancy check is basically used for error detection and correction. Through this CRC, we can detect error and also correct that error which was generated in a transmission channel. For that, there is a generator polynomial which is commonly available as a key to check the error and detect the error at the transmitter and receiver. Let's see the process how the cyclic redundancy check runs. As you can see on the screen, there is a data word as an input in the cyclic redundancy check. Initially there is a zero, there are some zeros are appended with the data word. Then in the next step, that new data word will go on through the modulo 2 operation with our generator polynomial, which we are called as a key. Now the output of that modulo 2 operation will be appended to our main data and it will be transmitted. In the receiver side, again the same process will be repeated. In receiver side, if our modulo 2 operation output remains 0, then there is no error and that will be accepted data. And for non-zero reminder, we can conclude that there is definitely some error in our transmission channel. Now let's visualize this whole process through the Java code. Let me show you my Java code for cyclic redundancy check. So this is my Java code and I am going to compile this. So typing enter. This information about CRC, and here you can see the algorithm of my code. In the algorithm, in first step, we are taking a date and key from the user. Then we are appending a 0 of data for k minus 1 time. There is a k is the bit or k is the number of bit. Then we are performing the modulo 2 operation and the remainder will be appended to our main data and transmitted to the receiver. In the receiver side, the process will be repeated. If there is a zero reminder, so we can conclude that there is no error, and if there is a reminder, there is a non-zero, then there is something error. For that we have to do further operation. Now let's go into the code. So here we are giving a data to our input, and here is a two generator polynomial, and I am selecting one of the two generator polynomial. Let's see, take key 1101. For that, you can see here all the modulo 2 operation and its remainder is appended to our main data. And here we are generating an error to show the demo of our real situation. So I am inverting the first bit and I'm creating the test error which will transmit the data. So receiver receive the data, there is an error. So now I am clicking on error correction. So we are receiving correct data. So I will explain the error correction part. For error correction, we are using a syndrome table. Let me show you my syndrome table which I created earlier. A syndrome table is used for find a particular location of error in our data. For error correction, we compare our receiver side reminder with the syndrome table, which will give you exactly location of the error. Here we can find the limitation of the cyclic redundancy check error correction, that it can correct only 1 bit error. There is one more thing for the note down, that the syndrome table for a particular key is pre-stored in a device. Let me show you what will happen when we are try to correct the error on more than 1 bit. Again we will move to the my Java code for the cyclic redundancy check. Again I am running the code, enter. I am repeating that same process at initially by choosing different key, inverting on the 2-bit. I will invert 0 and here 0. Now test error. Now we are received data, there is a more than 1-bit error, so there will be, the message will be shown us that it is only capable to solve 1-bit error. Though we will try to correct the error. Let's see what will be the output. Here we are getting a wrong output, which is the limitation of cyclic redundancy check error correction. Thank you for watching a video, guys.